Clustering as a general is technique that most of the humans do in their life. You'll find countless examples of clustering around you. For example, a group of people sharing a same table in a restaurant, or in a food store where you see similar items such as different types of vegetables or meat are displayed in the same or nearby location. So let's move on and understand more about clustering in detail. So hello and welcome all to this YouTube session. I'm Atul from Edureka, and as a part of today's session, I'll be teaching you about clustering. Out of several types of clustering available, today our main focus in this session will be on k-means clustering. So
Ya, beri pengantar tentang clustering bahwa banyak sekarang dalam kehidupan ini yang membutuhkan proses clustering. Ya, ini dari Edureka dan mereka akan menjelaskan apa itu clustering. Kemudian salah satu teknik clustering yang populer yaitu k-means clustering. K-means clustering bacanya ya. Itu akan dijelaskan.
let me tell you more about what we'll learn today or how this session is designed. Well, this k-means clustering session is designed in a way that in the first part you get your basics cleared and understand the concept and the algorithm behind it.
Ini akan dipelajari apa itu clustering, jenis-jenis clustering, apa itu k-means clustering, bagaimana k-means clustering bekerja, dan implementasi k-means dengan menggunakan Python. Ya.
Once you get comfortable with it, we will start its implementation using Python. I've added some real-life scenarios to give you a proper understanding of the topic. So in short, you can say that these are the agenda for today's session. We'll be learning about what is clustering, types of clustering, what exactly is k-means clustering, how does k-means algorithm work, and then finally we'll implement k-means using Python. Yeah, one more thing. This implementation part would be divided into two different parts, right? In the first part, we'll learn how to implement k-means using Python from the scratch, all right? And in the next part, we'll be using Python inbuilt library for implementing k-means algorithm, all right? And then finally, we'll compare output of them. Since you guys know that the main topic of discussion for this particular session is on k-means clustering, but before I dive deep into it, let me ask you a question. Do you guys know what exactly is clustering? Because it's very important that you know about clustering before we drill down to see what exactly k-means clustering is. So any answer, anyone? Okay, just let me tell. So what is clustering? In simple words, if you want, clustering is nothing but creating different groups. The groups consist of similar elements. If you want a definition kind of thing, then you can define clustering as a process of dividing the data sets into groups consisting of similar data points. The point within one cluster are as similar as possible, whereas the point belonging to other cluster are completely different from the points.
Jadi, clustering adalah proses membagi dataset. Dataset adalah kumpulan data ke dalam kelompok-kelompok ya yang berisi data poin yang sama. Ya, jadi data-data yang sama, titik-titik yang sama yang dimasukkan dalam grup yang sama atau dalam kelompok yang sama itu diusahakan sesama mungkin, sesimilar mungkin. Ya, data-data yang berada pada grup yang berbeda diatur supaya seberbeda mungkin. Ya, jadi data yang sama dimasukkan dalam kelompok yang sama. Itulah intinya ya. Data yang nggak sama ya ditaruh di kelompok yang lain.
In the first cluster. All right. And yes, one more thing, clustering is often referred as an unsupervised learning technique. Now you would ask that what is the use of clustering or where is it used? All right. So it is very important to know.
Clustering ini masuk dalam kategori unsupervised learning. Kemarin kita sudah bahas supervised learning, unsupervised learning, reinforcement learning. Clustering termasuk kategori unsupervised learning yang tidak menggunakan label, tidak ada labelnya. Ya, kalau supervised learning itu ada labelnya, unsupervised learning itu tidak ada labelnya. Nah, clustering ini masuk kategori unsupervised learning.
So where it is used. So let's understand clustering with an analogy. So in my introduction part, as I said that a group of diners sitting in a restaurant is an example of clustering. Let me tell you how you can connect it with the definition of clustering. All right. Suppose there are two tables in a restaurant. All right. Table T1 and table T2. The group of people sitting on the table T1, they might be related to each other, right? They may be a group of family members, they may be a group of colleagues or anything, right? Even the people sitting on table T2, even they are connected with each other, but only among the people sitting on table T2, right? But when it comes to comparing the people sitting on table T1 to the people sitting on T2, you'll see that they are entirely different. They are not at all related with each other. All right. So this clustering is also done in the same way. What is it? It's that the data points within one cluster is entirely different from the data point of the other cluster. All right. And all the points within the same cluster are either same or are related to each other. All right. Next was the items arranged in a mall. Remember when you visit Walmart or a retail store, you would find that similar items are grouped together for you. It's not like the items are just placed anywhere or mixed with each other. Like in the fruits and vegetable section, you won't find that apples and oranges are mixed with each other and placed on.
Ini dijelaskan bahwa sebagai contoh nih, orang kalau pergi ke restoran biasanya yang duduk bersama-sama pada meja yang sama itu punya kesamaan, ya, apakah teman-teman bersama atau satu keluarga bersama gitu ya. Di meja yang lain mereka juga punya kesamaan di dalam meja itu, orang-orang yang ada yang makan di meja itu. Tapi antar satu meja dengan meja yang kedua itu orangnya saling nggak kenal gitu. Nah, itulah clustering. Ya, jadi clustering itu benda-benda atau objek-objek itu berkumpul sesuai dengan kesamaan yang ada pada diri mereka. Ya, kalau orang sama-sama satu keluarga atau sama-sama satu kantor, ya sama-sama satu hobi, itu kumpul bareng-bareng gitu ya. Kalau yang berbeda hobi, beda keluarga, beda kantor, mereka akan kumpul dengan di klaster yang lain bersama dengan orang-orang satu klaster. Demikian juga kalau Anda pergi ke supermarket ini misalnya ya, pergi ke supermarket, supermarket itu atau mall itu akan mengelompokkan buah-buah sesuai kelompoknya. Ya, jeruk dikumpulkan dengan jeruk, apel dengan apel, pisang dengan pisang, begitu ya. Jadi nggak mungkin nih diacak-acak begitu, ada jeruk campur pisang campur mangga, ya. Nah itu namanya clustering. Ya, jadi buah-buahan yang ada di mall ini dikelompokkan sesuai dengan kesamaannya. Ya, sama-sama buah apel jadi satu, sama-sama buah jeruk jadi satu, sama-sama buah mangga jadi satu dan seterusnya. Itu namanya clustering.
The shelf, right? So what they do, they create groups and cluster of items for you so that you can easily shop and find your things from it. All right. It's like same variety of apples are placed in one place while the other varieties of apples are placed in another. You won't see the mix match of red and green apple, right? So when this is clustering. All right. So let's move ahead. Now the next question comes, where is it used? So let's see one by one. Flickr Maps, a photo and other map sites uses clustering to reduce the number of markers on a map. Even the Amazon is using the popular recommendation system, which is using the clustering to show you the recommended list of product according to your past purchase history. And yes, even the Netflix, it recommends you the movies based on your watch history, right? Whatever you have watched, it will show you some similar movies related to it. All right. So how do you think these recommended lists are generated? Well, all the concept lies behind this clustering. All right. Well, in general, you can say that clustering can be used to segment the customers or market in the marketing. It can be used by the social network site in marketing new groups based on users' data.
Nah, penerapan clustering yang lain, ini di Amazon misalnya, kalau Anda beli barang di Amazon, atau sekarang Anda belanja di Tokopedia atau di Shopee, biasanya kemudian Tokopedia, misalnya Anda beli tas gitu ya, beli tas di Tokopedia. Tokopedia biasanya kemudian menampilkan tas-tas yang lain yang sejenis dengan tas yang sedang Anda cari, gitu kan. Anda beli ke Shopee, beli sepatu, Tokopedia, Shopee akan menampilkan sepatu-sepatu yang lain yang mirip dengan sepatu yang Anda cari. Ya, itu namanya clustering. Jadi menggunakan teknik clustering, sistem akan mencari benda-benda yang mirip dengan benda yang kita cari atau benda yang ada supaya dikumpulkan gitu. Netflix begitu juga ya. Dia akan mencari movie-movie, film-film yang sesuai dengan apa yang Anda sukai. Ya, misalnya Anda suka nonton film horor gitu, dia nanti akan merekomendasikan tuh, namanya recommender system. Ya, recommender system ini dia akan merekomendasikan film-film horor yang lain yang ada di Netflix untuk Anda tonton. Ya, Flickr gitu juga ya, foto-foto yang mirip dengan foto yang Anda sukai, dia akan kumpulkan dan akan direkomendasikan untuk Anda pilih gitu. Jadi ini luar biasa ini metode clustering ini ya penerapannya.
Yeah. All right. So let's move on and see how business is using clustering. Well, clustering can help the business to manage their data better. Generally, they use clustering for image segmentation, grouping web pages, market segmentation, and information retrieval. For example, in a retail business, the data clustering helps in analyzing the customer shopping behavior, sales campaigns, and customer retention. In case of insurance company, a clustering is deployed in the field of fraud detection, risk factor identification, and customer retention efforts.
Ya, di dunia bisnis clustering juga sangat membantu ya. Di retail store tadi, toko-toko tadi, dia akan bisa melihat barang-barang mana saja yang laku begitu ya. Di toko itu barang jenis apa yang paling laku, berapa banyak lakunya ya. Per jenis barang, bukan per merek. Jadi kan ada kelompok-kelompok barang, nah itu akan bisa ditemukan. Di banking itu juga. Jadi bisa mengelompokkan nasabah-nasabah berdasarkan lokasinya, berdasarkan banyaknya uang, banyaknya transaksi dan segala macamnya. Banyak kriteria-kriteria yang bisa digunakan untuk mengelompokkan nasabah. Perusahaan insurans begitu juga ya. Intinya di dunia bisnis proses clustering ini sangat dibutuhkan untuk mengelompokkan nasabah, mengelompokkan ya customer atau nasabah sama aja ya, berdasarkan berbagai fitur yang ada pada diri nasabah.
While in the case of banking sector, you can use it for customer segmentation, credit scoring, and analyzing customer profitability. All right. So this is how the clustering is used in various business. All right. Let's move ahead. Let's see what are the different types of clustering. Well, we have mainly three different types of clustering: exclusive clustering, overlapping clustering, and hierarchical clustering. Let's start with exclusive clustering. Well, this exclusive clustering is a hard clustering in which the data points or the items exclusively belongs to one cluster. An example of such clustering can be a k-means clustering. In the examples shown below, you can see that all the blue data points lie within the blue cluster, and all the pink data points, they lie within the pink cluster. Both these clusters are entirely different from each other. They are not at all related with each other. All right. So this is how it's an example of exclusive clustering.
Ya, ini barusan menjelaskan tentang exclusive clustering. Ini nanti salah satunya k-means. Jadi satu objek itu betul-betul tergabung hanya dalam satu cluster. Ya, nanti ada contoh, satu objek bisa masuk ke dalam lebih dari satu cluster.
Next comes the overlapping clustering. Well, this overlapping clustering is a soft cluster in which the data points or the item belong to multiple cluster. An example of such clustering can be fuzzy or C-means clustering. Even in the diagram, you can see that some of the blue data points are overlapping with the pink data points. All right. So this is what happens in a C-means clustering or the fuzzy clustering. This is what a overlapping clustering is. All right. Fine. Next comes the hierarchical clustering. Well, let's understand hierarchical clustering with this example. Let's consider case 1. For instance, consider that we have 6 data points, A, B, C, D, and E, out of which A and B are similar and D and E are similar. All right. So in the first case, what we are doing, we are combining A and B based on some similarity, and we are combining D and E even based on their similarity. All right. In the next part, what we see that the combination of A and B is quite similar to C. So we are combining the combination of A and B with the C. All right. And similarly in the
Dia sedang cerita proses hierarchical overlapping udah tadi ya, mudah ya. Hierarchical clustering ini misalnya kita punya A, B, C, D, E, F gitu. Yang pertama A dan B itu similar, dekat begitu ya. Dekat, lalu kita hubungkan seperti ini. D dan E dekat, kita hubungkan ya. Ini kalau di gambarnya seperti ini. Nah, kemudian kita melihat hubungan antara AB terhadap C. Ya, hubungan dari AB terhadap C. Ini. Hubungan AB terhadap C bisa diukur dari titik terdekat atau titik terdekat dari anggota klaster AB ini terhadap benda yang baru yang ada di luar. Dalam hal ini B. Oh, ini dekat. Berarti ini digabungkan dalam satu klaster. Dibuat tanda hierarkinya. Ya, jadi AB dekat dengan C. Jadi ini bisa satu klaster. Ya, kemudian DE dengan F ini diukur. E dekat dengan F maka satu klaster gitu ya. Nah, ini namanya hierarki. Jadi kita nanti bisa menentukan jumlah klaster itu berdasarkan hierarki ini. Kalau kita mau jadikan semua satu klaster berarti semuanya. Kalau dijadikan 2 klaster berarti A, B, C, D, E, F. Kalau mau dijadikan 3 klaster nggak bisa. Jadikan 4 klaster, berarti D, E, F, A, B, C gitu ya. Itu gunanya hierarki, clustering.
The third part, we see that the combination of D and E, it is quite similar to F. So we are combining the combination of D and E with F. Okay. And the final fourth part, we see that the final tree contains all the cluster combined within a single cluster, as the combination of A, B, C is quite similar with the combination of D, E, F. Okay. So the final tree contains all the cluster combined into a single cluster. All right. So this is what a hierarchical clustering is and how it works. Okay. An example of hierarchical clustering can be a dendrogram. All right. Till now, we have covered about what is clustering, where it is used, how the business is using clustering, and what are the different types of clustering available. All right. Now, since our main focus would be on k-means clustering, so let's focus on that. So, what is k-means clustering? Well, k-means is a clustering algorithm whose main goal is to find the groups in the data. The number of groups or cluster is represented by k. The algorithm then runs iteratively to assign each data points to one of the k groups based on the features that are already provided. Okay. Now let's understand this k-means clustering with an analogy. Suppose that to assign each.
Bentar. Dia menjelaskan definisi dari k-means clustering. K-means adalah algoritma clustering di mana tujuan utamanya, main goal nih sebetulnya ya, adalah mengelompokkan similar elements, elemen-elemen yang sama atau poin-poin data yang sama ke dalam sebuah cluster. Gitu ya. K di k-means ini merepresentasikan jumlah cluster. Jadi k-means ini berarti kalau jumlah clusternya 3 berarti 3 cluster gitu ya. Kalau huruf K-nya 3, huruf K-nya 5 berarti 5 cluster.
Data points to one of the k groups based on the features that are already provided. Okay. Now let's understand this k-means clustering with an analogy. Suppose that you are shifted to your hostel and you don't know how to wash your clothes. You have to do your laundry on your own. All right. So at the end of the month, you see that you have collected a big pile of clothes for you and they're waiting for you to wash them. So how will you do that? So what you did, initially you called your mother. You asked her how to wash these clothes. She said that there are specifications for each variety of clothes. Okay. Some are washed in hot water, some in cold, some can be put in the dryer, some need air drying, and so on. There are various specifications for various clothes. All right. To make this a clustering scenario, let's assume that your mother asked you to divide into 3 parts. Okay. She asked you.
Ini mau memberi contoh ya, dalam dunia nyata misalnya Anda diminta untuk mengelompokkan baju-baju ini mau dicuci gitu ya. Bagaimana Anda cara mengelompokkannya? Gitu ya. Bisa dikelompokkan dalam 3 kelompok, 4 kelompok, 5 kelompok ya. Tapi apa yang membedakan satu kelompok dengan kelompok yang lain gitu ya. Misalnya baju-baju yang kecil taruh di satu kelompok, celana-celana jeans yang bahannya berat-berat satu kelompok lagi, kan gitu biasanya. Jadi jangan dicampur antara kaos dalam, celana dalam begitu ya dengan celana jeans, hancur nanti ya. Nah, itu namanya clustering. Jadi mengelompokkan benda-benda atau objek berdasarkan kesamaannya.
To pick 3 different items of cloth at random, and that will be the starting point for those 3 separate clusters. And then again you have to go through that massive initial cluster and look at each item of clothing in turn. Now at this point of time, you have to compare the attributes such as water temperature, drying temperature, color with each of the 3 starting item, and then place the new item into the best cluster or the best pile. Okay. So what do you think is the definition of a best cluster or a best pile? Well, it is not based on a whole cluster. It purely relies on the starting point. Technically, that starting item is known as centroid. But don't worry about that, we'll get to know about that later. These items won't be identical. So pick the best match. If you want to be really detailed about this, so what you have to do, you're asked to place each item closer to or farther away from the starting item based on how similar they are. That is, you can say that the more similar is the item, the more closer it will be to the starting point. Okay. Now you have got 3 different cluster, which means you are ready to use the washing machine. But not so fast, we are just getting started. Well, there's a very iterative process. And the next step would be to determine the new centroid for each of those pile or each of those cluster and repeat the process. Those new centers would be calculated and may not correspond to an actual item of clothing. And we really don't know if these 3 clusters are optimal number. So once you have completed the iteration with 3 cluster, you should go and try with 4, 5 and more. Now this is what k-means algorithm was. Don't worry, we'll see more details about it. But first let's see where you can apply the k-means algorithm. The k-means algorithm can be applied to a numeric or continuous data with smaller number of dimension. It can be applied to any scenario where you want to make groups of similar things from randomly distributed collection of things.
Ini contoh penerapan k-means clustering ya untuk mengelompokkan dokumen-dokumen ya. Jadi di sini ada dokumen-dokumen, kemudian ini proses trainingnya, sebelah kiri ini proses trainingnya. Proses training adalah proses bagi sistem untuk mengenal ciri yang sama dari suatu dokumen. Misalnya yang satu misalnya dokumen skripsi, satu lagi dokumen misalnya KRS begitu ya. Nah kan ada cirinya. Nah si mesin kita beritahu dulu kalau dokumen skripsi itu seperti ini cirinya, ada halaman pengesahan, misalnya jumlah halamannya banyak dan seterusnya. Kalau KRS satu halaman saja dan seterusnya. Nah berdasarkan ciri-ciri ini nanti yang sebelah kanan ini dokumen-dokumen yang banyak ini dikelompokkan ya, automatic classifier udah bisa mengelompokkan, oh ini skripsi, oh ini KRS gitu ya, berdasarkan ciri-ciri yang sudah dipelajari sebelumnya dalam proses training.
For example, document classification, where you can create the clusters of document in multiple categories based on tags, topics, and contents of the document. This is a very standard classification problem, and k-means algorithm is one of the highly suitable algorithm for this purpose. Now let's proceed and understand about k-means algorithm in depth. Imagine you have some data, and your task is to plot the data points on the graph and divide the points into 3 different clusters.
Kita masuk ke cara kerja algoritma k-means. Tolong diperhatikan ya. Jadi kita akan membagi objek-objek ke dalam beberapa cluster. Contohnya kita punya 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 objek. Ini kebetulan sudah diwarnai objeknya. Asumsikan kalau komputer itu kan tidak punya mata. Jadi komputer tidak tahu objek itu ada di mana. Ya.
Now these 3 clusters may represent 3 different categories of, suppose, bikes in the dataset. It might be a cruise, sports, or touring bike. Okay. So in this case, you can see the exact data points within each cluster. But rather than just relying to our eye, let's see if our computer can show us the same result or not. That is 3 clusters. In order to perform this, I'll be using the k-means clustering. Now let's suppose this is our unclustered data. So to start.
Jadi asumsi awal semua data ini belum tercluster. Ya, kita nggak tahu hubungan antara satu data dengan data yang lain, seberapa tingkat kedekatannya dan seterusnya kita nggak tahu. Ya.
Start with, at step 1, you will select the number of cluster you want to identify in your data.
Tahap pertama adalah menentukan jumlah klasternya dulu. Nah, dengan k-means ini di awal kita tentukan, saya mau benda-benda ini dikelompokkan ke dalam 3 klaster gitu misalnya. Ya, ke dalam 5 klaster itu kita yang menentukan. Ya, nilai K-nya kita yang menentukan di awal.
Let me tell you a fact that this K in k-means is nothing but the total number of clusters you want. Suppose if K equals 3, then total number of cluster is also 3. Okay. So in this case, it's K equal 3, as it is mentioned already that we want to create 3 clusters. There's also a very cool way to select the number of K, but we'll discuss about it later in this session. Okay. In step 2, what we do, we randomly select 3 distinct data points.
Nah, langkah kedua adalah secara random memilih 3 data point yang berbeda. Ya, dari data yang ada kita pilih 3. Random, yang mana aja. Ya, bisa jadi begini, bisa jadi 3-3-nya di sini, kita nggak tahu. Ya.
These are the initial 3 cluster consisting of just one single data point. Okay. These 3 points are nothing, but we are assuming that they are the centroid of each cluster. Okay. Now, as a step 3, what we'll do, we'll measure the distance between the.
Nah, setelah kita menentukan 3 data point yang kita tentukan di awal tadi, kita akan berasumsi 3 data point ini menjadi pusat cluster. Ya, menjadi pusat cluster. Kan kita sudah menentukan tadi K-nya 3, berarti kita akan membuat 3 cluster. Ya, 3 cluster, kita pilih 3 data point, misalnya ini merah, biru, dan hijau. Kemudian langkah ketiga, kita akan mengukur jarak antara titik poin yang pertama, ini dari semua titik ini eh, ke masing-masing klaster. Jadi ini nanti akan mewakili klaster 1, mewakili klaster 2, mewakili klaster 3 gitu ya. Jadi setiap satu poin ini diukur jaraknya dengan ini, diukur jaraknya dengan ini, diukur jaraknya dengan ini, gitu ya.
First point and the 3 clusters. So this shows the distance from the first point to the red cluster. Next, it shows the distance from the first point to the blue cluster. And this, it shows the distance from the first point to the green cluster.
Ya, jadi titik yang pertama kita ukur jaraknya terhadap yang merah. Kita ukur jaraknya terhadap yang biru. Kita ukur jaraknya terhadap yang hijau. Untuk menentukan si titik pertama ini lebih dekat ke klaster yang mana. Ini kalau kita anggap ini titik pusat klasternya, titik pusat klaster merah, titik pusat klaster biru, titik pusat klaster hijau. Ya, kita ukur setiap titik ini terhadap 3 titik pusat klaster, centroid namanya. Ya.
Alright. Moving on to step 4, what we'll do, we'll assign the first point and add the first point.
Ya, karena titik pertama ini jarak paling dekatnya dengan titik merah, ya sentroidnya merah, maka dia kita tandai ini berarti masuk ke klaster merah gitu ya.
Into the nearest cluster. Since in this case the nearest one is red, so the first point will be added to the red cluster. Fine. As a step 5, we'll calculate the mean for the red cluster including the.
Nah, setelah itu kita menghitung langkah 5, calculate the mean value including the new point for the red cluster. Jadi kita menghitung berapa nilai rata-rata antara 2 titik yang berada pada klaster yang sama. Ya, makanya namanya K-means. Means itu kan rata-rata. Kita hitung 2 titik, kita hitung nilai rata-rata dari titik-titik yang ada dalam klaster itu. Sekarang kan kita punya 2 anggota nih, klaster merah punya 2 anggota, nilai rata-ratanya berapa? Nah, ini titiknya nih, yang garis merah ini.
New point which is recently added to the cluster. So the mean value in this case lies somewhere here in between the 2 points within the red cluster. Okay. Now we are done with first point. We know that the first point lies within the red cluster. Now let's figure out the cluster of the second point, or in other words, to which cluster does the second point belongs to. Well, to do this, you can use the same procedure you used for the first point. It's just that we'll now.
Setelah itu kita melakukan hal yang sama untuk titik kedua, ya, titik ketiga, titik keempat dan seterusnya. Ya, tapi untuk titik sentroidnya bukan lagi di merah ini, tapi di garis ini. Jadi titik kedua dihitung jaraknya terhadap garis merah. Di titik ketiga, dihitung dengan jaraknya dengan garis merah, dihitung dengan titik biru, dihitung dengan titik hijau. Mana lebih dekat? Karena lebih dekat dengan titik merah, berarti dia masuk ke klaster merah. Yang 3 begitu juga, hitung jaraknya terhadap yang garis merah, hitung jaraknya terhadap biru, hitung jaraknya terhadap hijau, masih dekat dengan merah. Yang ini juga dihitung. Mana lebih dekat dengan titik merah, apa lebih dekat dengan titik biru? Kalau lebih dekat dengan titik biru, berarti ini anggota biru nih. Ya, yang ini nanti dihitung juga dengan biru, dengan merah, dengan hijau. Mana lebih dekat? Gitu ya. Jadi iterasinya dilakukan terus sampai semua titik itu tidak bergerak lagi.
Now measure the distance of second point from the red mean. So here is the different distance of second point to different red, blue and green clusters. Once you are done with measuring, assign the second point to the nearest cluster, which is again the red cluster. Alright? Next, we'll use this new point to calculate the mean within the red cluster.
Setelah dapat titik yang ketiga sebagai bagian dari klaster merah, maka nilai sentroidnya, nilai rata-rata dari klaster merah itu dihitung ulang. Karena dia punya 3 anggota sekarang. Merah ini, merah yang kedua, merah yang ketiga. Nilai rata-ratanya dihitung ulang. Ya, dia bergeser ke kiri sedikit.
As you can see, this new mean is shifted to the left just a little bit, right? So now we know about our second point as well, even it lies within the red cluster. Now let's see and find out to which cluster does our third point belongs to. So what we need to do, again measure the distance, assign the point to the nearest cluster, and then finally calculate.
Ya, ini sedang menjelaskan titik ketiga, poin ketiga yang ini dihitung jaraknya terhadap yang merah, terhadap yang biru dan terhadap yang hijau.
The new mean for the red cluster, as this particular third point, even this belongs to the red cluster. Alright, now let's move on to see which point does the fifth point belongs to. Again, follow the same method.
Nah, hal yang sama dilakukan juga untuk titik yang ini. Ya, ukur jaraknya terhadap biru, ukur jaraknya terhadap merah, ukur jaraknya terhadap hijau. Ya.
Third, measure the distance, assign the cluster, and once again calculate the new mean. For this case, for the fifth point, you can see that it belongs to the blue cluster and it is a blue point.
Ya, karena dia dekat dengan biru, maka anggota biru. Kemudian titik yang ini dihitung lagi. Jaraknya terhadap biru, jaraknya terhadap merah, jaraknya terhadap hijau. Ya, mana yang lebih dekat?
Okay. Now let's find out to which of the cluster does this point belongs to. Again, measure the distance, assign the cluster, calculate the new cluster mean. The rest of these points will always be closest to the green. So all of these will fall under the green cluster.
Ya, karena semua ini nanti dilakukan hal yang sama ya. Untuk semua titik dilakukan hal yang sama. Diukur terhadap tiga titik tengah cluster. Ya, mana yang lebih dekat? Yang kelihatannya kalau ini kan secara cepat aja, ini lebih dekat ke yang hijau ya daripada yang biru dan yang merah.
Now it's time we compare our result to the original one. Oh what? The K-means clustering algorithm or the machine is giving a very poor result compared to what we did by eye.
Jadi hasil dari iterasi yang pertama tadi ya dengan cara mengukur setiap titik itu terhadap titik pusat cluster, hasilnya seperti ini, merah, biru, nah ini masih hijau di sini ya. Padahal yang kita lihat secara mata yang tengah ini biru nih semuanya nih harusnya nih karena dia lebih dekat dengan biru. Ini baru iterasi yang pertama karena dia akan melakukan beberapa kali iterasi, beberapa kali pengulangan perhitungan sampai mendapatkan situasi yang stabil yang nggak bergerak-gerak lagi. Nggak bergerak maksudnya nggak pindah lagi. Ini kan kalau dihitung ulang, hijau ini kalau dihitung ulang, ini kan titik tengahnya hijau ada di sini, titik tengahnya biru di sini. Ini kalau dihitung ulang dia akan lebih dekat ke biru ketimbang ke hijau. Ya, makanya di iterasi kedua dia akan bergeser nanti akan pindah ke yang biru, bukan lagi bergabung dengan yang hijau ya, titik ini.
Well, you can always check the quality of the cluster data just by adding up the variance within each cluster.
Ya, ini titik tengahnya merah, titik tengahnya biru, titik tengahnya hijau. Ya.
So this is the sum total of variance within the three clusters. Well, there's a fact that K-means clustering cannot see which one of them is the best clustering. But what it does, it keeps a track of these clusters.
Jadi algoritma K-means ini akan bekerja ya dengan cara menghitung ulang setiap titik itu terhadap titik tengah sampai tidak ada lagi perpindahan satu titik atau satu objek dari satu klaster ke klaster yang lain. Artinya kalau udah nggak pindah memang itu udah jarak terdekat diri dia terhadap titik tengah klasternya.
And their total variance, and repeat the same steps from the scratch but with different starting point. So let's see once again, we are here at the beginning to choose 3 random points, but yeah, make sure that these 3 random points are completely different from those random points which we had selected in the very beginning. Okay, so algorithm, what it does, it picks 3 initial cluster and then it adds the remaining point to the cluster having the nearest mean. Again, recalculating the mean each time a new point is added to the cluster. Now, once we have the cluster data, we'll calculate the sum of variation within each cluster. And again, repeat the same steps again and again. Pick 3 initial cluster the remaining point, and finally take the sum of variation within each cluster. Now at this point, our algorithm knows that is the best clustering so far.
Ya, seperti saya sampaikan tadi, jadi ada pengulangan, ada iterasi proses berulang-ulang ya. Ini sampai 3 kali pengulangan baru stabil nih. Karena pengulangan keempat hasilnya akan sama dengan iterasi keempat, hasilnya akan sama dengan iterasi ketiga. Itu artinya objeknya tidak akan bergerak lagi, tidak akan berpindah klaster lagi. Kalau udah sampai titik itu berarti sudah selesai prosesnya.
As it has the lowest sum of variation. But even now the algorithm is not completely sure of the cluster. So it will repeat itself and check for few more cluster. Now you might be wondering when this algorithm would end. Well, it depends on how many iteration you want to perform. It would do as many as you want it to do. Suppose I say I want to perform 20 iteration, so the machine will iterate 20 times and then finally return the result. It's not like if you perform 20 iteration, you will be getting 20 different cluster. It's just that it will execute 20 times even though the result is same. By same result, I mean that the cluster created would stop changing after few iterations. Alright. When manually calculating, we generally stop the calculation when we get the same result consecutively, as we want to get sure of the result. Even though you repeat, you would get the same result. Okay. Now what if we have a 2D data plotted on a graph with X and Y axis? So even for this case, we'll
Hal yang sama bisa dilakukan juga kalau kita punya data berupa titik-titik yang ada dalam koordinat gitu ya. Koordinat X, koordinat Y. Kita nanti akan bisa melakukan hal yang sama, perhitungan titik tengahnya, menghitung jarak dari setiap objek terhadap titik tengah klaster, kemudian mengelompokkan klaster itu ke dalam kelompok klaster terdekat, ya, berdasarkan jarak terdekatnya.
start with picking up 3 random points, which will be their centroid. But in
Jadi diawali dengan K-means itu diawali dengan menentukan 3 titik random ya yang diasumsikan di awal itu sebagai titik tengah klaster. Di awal random dulu ya, ditentukan, nanti baru diukur jarak dari setiap titik terhadap 3 titik random itu. Nah, 3 titik random ini nanti akan menjadi penentu titik rata-ratanya ada di mana posisinya.
this case, we'll use the Euclidean distance to find the distance between the 2 points. In case of 2D, this Euclidean distance is same as that of a Pythagorean theorem. Alright.
Ya, untuk menghitung jarak antara 2 titik menggunakan namanya Euclidean distance. Ya, pakai Pythagoras ya. Teorema Pythagoras. Jadi jarak antara yang titik merah ke titik ini sama dengan ini akar dari nilai kuadrat jarak ini ditambah nilai kuadrat akar ini. Ini ya, H kuadrat sama dengan L kuadrat ditambah B kuadrat.
That is h square equal L square plus B square, where h is the hypotenuse, L is the length or the height, and B is the base. Okay. Then just like before, you will assign the point to the nearest cluster. Finally, calculate the mean of the cluster with the new point in it, and we'll use this mean to determine the distance from the cluster.
Ya, setelah tahu ini jaraknya dekat, maka kita tentukan nilai titik kita tentukan posisi means, nilai rata-rata dari anggota klaster yang baru bergabung ini, kan baru 2, titik tengahnya di sini. Nanti kalau bergabung lagi beberapa titik, cari titik tengahnya di mana. Ya, nanti semua titik yang lain akan diukur berdasarkan titik tengah dari masing-masing klaster. Dan dia akan termasuk ke dalam klaster yang mana tergantung dari jarak dirinya terhadap titik tengah klaster.
Yeah, we need to pick a bunch of starting points before finalizing the cluster. Alright. Now coming to one of the most important question, how will you decide what value should you use for K? Well, sometimes you will find that the number of cluster to create.
Ini sekarang kita akan membahas sebentar atau sedikit tentang bagaimana cara menentukan nilai K-nya. Ya, bagaimana cara menentukan nilai K. Ya, karena kan jumlah klasternya kita nggak tahu yang ideal itu berapa, apa 3 atau 4 atau 5 begitu ya.
Obvious, like K equal 3. But sometimes it is not that easy to judge or guess the number of cluster manually. So what we'll do in this case? Well, one of the options to decide the value of K is the hit and trial method, where you just need to try different values of K. So starting with the minimum possible value of K, that is K equal 1, with symbolize.
Jadi ini caranya diskenariokan ya, disimulasikan. Mulai dari K1, K2, K3, K4, K5, dan seterusnya. Untuk menentukan K berapa yang paling tepat begitu untuk sekumpulan data yang kita punya.
Is that all the data points lie within one single cluster. K equal 1 is the worst case scenario. You can even decide it by calculating its total variance. Alright, by this what I mean to say, suppose you have 20 data points, alright, and you are creating 20 cluster. So this would be the worst case scenario if all the 20 points are lying within the 20 different cluster. Alright, now let's try with K equal 2. Still better, but how much better? Well, why don't you compare it with the total variation with K equal 2 to K equal 1? That is compared when we had 2 cluster.
Ya, kalau dijadikan 2 cluster, kalau satu cluster tadi semua merah. Kalau jadi 2 cluster, hasilnya seperti ini. Ya, ini sedang mencoba mensimulasikan nilai K-nya.
When we had 1. Now let's try K equal 3. Well, in this case, it's even better. But how much better? Well, even in this case, you can decide it by comparing the total variation within the 3 cluster, that of the 2. Okay. Now try with K equal 4. In this case, the total variation within each cluster is less than when K equal 3. Each time we increase the number of cluster, the total variation within each cluster gets smaller than before.
Jadi ini simulasikan ya, kalau nilai K-nya 4, 5, dan seterusnya. Setiap waktu Anda menambah jumlah klasternya, maka variasinya akan berkurang gitu ya. Jadi akan akan semakin berpencar gitu ya variasinya, karena kan jumlah klasternya makin banyak. Lama-lama kan jumlah klaster maksimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 klaster ini maksimal, masing-masing jadi satu klaster. Ya, kalau masing-masing satu klaster udah nggak ada jarak lagi satu dengan yang lain karena hanya pada dirinya.
And then finally, when we have the case where total number of cluster equal total number of points, or in other words, we have just 1 point per cluster, then in that case, the variation becomes 0, obviously, right? So you can say that the number of clusters are indirectly proportional to total variation. If the number of cluster increases, the total variation decreases. Finally, when we plot the reduction in variance for per value of k, we'll get a graph like this, where on the x-axis we have the number of cluster k, and on the y-axis we have reduction in variance.
Ya, nah ini jadi menentukan nilai yang paling ideal adalah ketika nilai variasinya itu kan dari 1 sampai ke 0. 0 itu maksudnya nggak ada perbedaan karena dirinya sebagai cluster yang 12 tadi misalnya ya. Nah, nilai cluster ideal adalah di titik perbelokan ini nih ya. Elbow point namanya. Elbow point ini adalah titik di mana perbedaan antara kelompok-kelompok objek itu bisa dilakukan dengan lebih jelas begitu ya.
In the graph, you can see that there's a huge reduction in variance with k equal 3. But after that, there is no such steep change in the variation. So this point of change is known as the elbow point. And the value of this point is the one which decides the value of k. That is, in order to find out the value of k, you need to find the elbow from the elbow plot. Okay, fine. This was all about k-means algorithm, how it works. Alright, now let's move to the coding part. But before we dive into it, let's understand the algorithm on the basis of the coding. Let's move towards the implementation part of k-means using Python. But before that, let me just summarize the algorithm for you. Okay, so what we do, initially we randomly choose.
Sebelum melihat pada codingnya, jadi ini summarize dari algoritma k-means. Pertama menentukan nilai k-nya, ya, kemudian membentuk K cluster, kalau K tadi 3 misalnya 3 cluster, dengan menempatkan setiap objek ke dalam centroid yang terdekat. Centroid ini titik pusat cluster. Ya, kemudian menghitung jumlah centroid yang baru. Kalau ada penambahan jumlah centroid, tadi kan pertama menentukan 1, kemudian 2, kemudian 3 gitu ya. Dengan membuat rata-rata dari objek-objek yang ada di dalam cluster ya, jadi nilai posisi centroidnya akan bergerak-gerak sesuai dengan nilai rata-rata dari setiap posisi dari setiap objek yang ada dalam cluster tersebut. Ketika centroid itu tidak bergerak lagi maka sudah selesai ya, kira-kira begini nih secara ringkas algoritmanya.
K examples as initial centroid, then while true, we create k clusters by assigning each example to the closest centroid. So first of all, what we do, we randomly choose k examples as initial centroids. Then we check the condition while true. Then what we have to do in that case? Unless and until it is true, we'll be creating k different cluster by assigning each example to the closest centroid. And then we'll be computing k new centroids by averaging examples in the cluster. And if the centroid doesn't change, that means we have found the exact number of clusters. Alright, and then break the thing. So this was a summary of a k-means algorithm. Now let's move on to the implementation part. Let's see how to implement k-means clustering algorithm in Python. So in the first step, what you'll do, you'll be importing all the important modules such as Panda, NumPy, sklearn, and pyplot. In the next step, you'll be importing the iris dataset into the Python, which is a very standard dataset for classification problems and can be downloaded from the UCI repositories.
Ya, ini contohnya codingnya. Yang pertama ini import library-nya, kemudian ini data frame, ini datanya. Ya, ini pakai data yang
in the third part, you'll view the dataset, study it, and then convert the dataset into Panda data frame. Alright. As a step 4, finally we'll perform the k-means analysis on it and see the result of the cluster as a cluster vector and also as a plot. Alright. And then finally we'll be using a Python library to implement the k-means clustering. Let's see how to implement k-means clustering algorithm in Python. So for this we'll be using 2 methods. The first method would be writing a k-means clustering program from the scratch. And the next method would be using a Python library, sklearn. So our first part in this implementation would be the initialization part. And how it is? We'll start by importing pandas, numpy, and matplotlib. Alright. Next, we'll define a panda data frame variable df such that the x coordinates are this and the y coordinates are this. All right. Next, what we are doing, we are defining a random seed as 200 and defining k for the k-means clustering.
Ya, ini menentukan datanya, kemudian menentukan nilai k-nya, ini k sama dengan 3, ya, secara random seed 200 ini, untuk menentukan nilai dari masing-masing cluster. Kan ada 3 cluster, titik tengahnya dipilih secara random pertama kalinya.
Or the total number of cluster that we want is 3. The next task is choosing the first centroid. Alright, fine. So these numbers lie between 1 to 80, right? So for choosing centroid, I'll be using any random number between 0 to 80. Fine. So here plot.scatter, what we are doing here, we are creating a scatter plot such that on x-axis there will be a data frame with the x array. We are passing this value of x array into the data frame, and next we are passing the value of y in the data frame, and we are defining color equals 3. That means we need 3 different colors as the number of k that is equal to 3. Alright, as a color map we are defining 1 for red, 2 for green, and 3 for blue.
Dia mau mendefinisikan ini, menuliskan 3 warna yang berbeda ya untuk 3 cluster, red, green, blue, begitu ya, untuk digambar nanti.
Right, and finally we are plotting it. Let's execute it and see what is the result we are getting. Okay, this star mark, it symbolizes that it is still executing, and once it will change to a numeric number, yeah, like it turned to 1. So it suggests that it has completed the execution and the output is ready. Okay, so this is the output which you will get.
Nah, ini outputnya ya, dari titik-titik tadi, koordinat tadi, X dan Y tadi. Jadi dia menentukan 3 random titik yang berbeda sebagai titik awal cluster, ya, merah, red, green, blue, merah, hijau, dan biru.
You can see that this red, green, and blue are 3 random data points which are initially selected as the centroids. Alright. Next is the assignment stage. I need to assign each point to one of the cluster. Alright. So let's execute it and see a sample output of it. Alright. So what we are getting here is that for the first point of coordinate 12 and 39, its distance from first cluster is 20.
Nah, ini tadi perhitungan tadi ya. Objek yang pertama, nilai X dan Y-nya sekian, jarak terhadap cluster yang pertama 26,9, jarak terhadap cluster yang kedua 56,08, jarak terhadap cluster yang ketiga 56,7. Jadi yang terdekat adalah yang 26 tentunya. 26 kan lebih kecil dari 56 dan 56. Jadi dia masuk ke dalam cluster yang pertama, yang warnanya merah. Jadi dihitung setiap titik itu, dihitung jaraknya terhadap titik centroid yang pertama. Nanti centroidnya bergerak, ya, tergantung dari nilai rata-rata semua titik yang ada dalam cluster itu, dihitung lagi setiap titiknya.
6.92, whereas its distance from second cluster is 56.08, while in case of third cluster, it's 56.72. What we'll do, we'll finally assign that point to that closest cluster, alright, which is 26 in this case. So the closest cluster is 1, and we have already defined the color scheme for 1 was red. Okay. Similarly for the second point, third point, fourth, fifth, and so on. Alright. What we have to do, we have to check the distance from first, second, and third cluster. Whichever is the minimum, we'll assign that particular point to that particular cluster. Alright. So this is done. So next is the update stage, where the centroids will be updated. Alright. So let's execute it and see. You can see that these are the updated centroids. The centroid are shifted somewhere in the middle of the screen cluster. Alright. So this update stage, what it did, it just updated the value of the centroid such that it lies somewhere between the cluster. Alright. Okay. Now this is done. Then what we have to do is,
ya, ini proses iterasi seperti yang saya jelaskan di gambar di awal tadi ya. Cuma ini kan pakai coding. Dia akan bergerak nilai centroidnya itu tergantung dari jumlah rata-rata dari posisi semua titik yang ada dalam cluster itu.
we have to again define the assignment stage. So we'll define a df variable consisting of assignment function, and that will pass the value of panda data frame and the centroids. Alright. And then again we'll plot this result. Okay. Let's see how it shows. Okay. Let's compare these two results. Are you getting any difference? Yeah. You can see that this particular blue point is changing to red in this graph, right? Okay. Now this process will keep on repeating until and unless all the assigned categories does not change anymore. Alright. Let's execute it and see. Okay, so let's compare the two results. Okay, even in this case, this blue, this is changed to red, and our centroid, which was initially positioned here, is changed to somewhere in the center of the cluster. All right, so this is our final result, and we have 3 clear cluster with 3 means at the center of these cluster. Now let's repeat the same task using this scikit-learn. We first
Ya, dia baru menjelaskan pergerakan dari objek-objek yang ada dalam satu cluster. Ya, seperti yang saya bilang tadi, jadi objek akan bergerak terus sesuai dengan tingkat kedekatan dengan titik cluster.
to our data. So for that, let's see.
Nah, di Python ada fungsi yang langsung nulis k-means begitu ya, nggak pakai proses panjang tadi nyari centroids-nya di looping segala macam. Ini udah ada function dari sklearn.cluster import k-means, udah langsung kita panggil k-means-nya saja.
Fine. Next, what we'll do, we'll define the data frames. Let's load our data and define the k-means. And k-means will be defining the total number of cluster as 3. All right. So here what we are doing, we are creating a variable for panda data frame, which will be storing the values of x and y coordinates. All right. Then from sklearn.cluster, we'll be importing the k-means. K-means is a predefined library which comes under the sklearn. We'll define the total number of cluster for k-means, and then finally we'll fit our data to it. All right. Let's execute it. Okay, so this is our output. The algorithm is auto, copy underscore x is true, and it is k-means plus plus. Maximum iteration possible is 300. Total number of cluster that I want is 3. Initial value is 1. Total number of jobs performed is 1, and so on. So next what we'll do, we'll learn the label, execute it, and then finally plot it. Execute it. But what we see that when we compare the result, the colors are in different order. There are some points which you can take note of. The k-means clustering is a very sensitive to scale due to its reliance on Euclidean distance. So be sure to normalize your data if they are likely to be scaling problem. If there are some symmetries in the data, some of the labels may.
Hasilnya agak berbeda. Yang hijau tadi masuk, kalau yang perhitungan secara manual tadi masuk ke biru, kalau ini masuk ke hijau. Ya, memang suka ada perbedaan-perbedaan, itu nggak ada masalah. Biasanya memang tingkat akurasinya tidak 100% nih untuk proses clustering seperti ini ya. Beda algoritma, nanti beda lagi.
We mislabel. It is recommended to do the same k-means with different initial centroids and take the most common label. All right. Well, thank you, folks. This was all about this session.
Okay.